what's the calculus actually? Is the mathematics in which we calculate the continuous changes of variables. Means what are those variables? The variable may be of any types. Maybe it is the speed of wind, maybe it's the ratio with which we are mixing the things, maybe the size of some object which is changes continuously, and any type of thing can be over there which we are going to calculate using calculus. The essence of my experience says that at first we should learn about functions in set theory, and then we should learn the types of functions. Also, we should learn about the concept of limits of functions, concepts of continuity of functions, and after that we can jump into this field and we will swim easily and enjoy our life forever in calculus. So let's start it now. Discussing and understanding about functions in set theory is rather convenient than try to understand them directly in other fields of mathematics and physics. So I prefer to build the concept about functions in set theory. But first I'll review a few terminologies of sets relevant to functions. For two sets A and B, if the elements of set A are also present in set B, then we say that set A is a subset of set B. Let's suppose that I'm taking two sets A and B such that the elements of A are 1, 2 and that of set B are 1, 2 and 3. So we can see here the first element of set A, 1, is also present in set B. Likewise, the second element 2 of set A is also present in set B. So we are writing a relation between set A and B, that is set A is a subset of set B, and mathematically we can write it as A. After that we are writing the symbol of subset, and then we are writing the other set B. We can read it as A contains in B, or we can read it as A is a subset of B. Here's a few extra information for you about sets. First thing is that phi, the empty set, phi, which is actually the empty set, is the subset of each and every set. The second thing is that every set is the subset of itself. I mean, A is fully contained in A, B is fully contained in B, means A is a subset of A, B is a subset of B. This is the thing which I want to tell you. Ordered pairs, as the name is suggesting that these are the pairs of numbers in which their order is important. So first I'll discuss about the multiplication of two numbers. We know that when we multiply two numbers, the answer of the multiplication is product. For example, I want to multiply two numbers 5 and 7. The product of these numbers will be a new number which is undoubtedly 35. Hence 5 multiplied by 7 is equal to 35. 35 is the product of these two numbers. Now let's revert to the concept of ordered pair. When we multiply two sets, the product is always a new set having its elements in the form of pairs. And those pairs are called ordered pairs because the order is of great importance. So let's start with an example. For example, I am taking two sets A and B such that the element of A are 1, 2 and 3 and element of B are 5, 6 and 7. If I'll multiply these two sets, I'll get a new set A cross B which will have its elements in the form of ordered pairs. That is, to get the ordered pairs in A cross B, I'll select an element from the first set and pair it with the elements of the second set one by one. Means first I'll make it pair with 5, then I'll make it pair with 6, and at the end I'll make it pair with 7. Means first pair is 1, 5, second is 1, 6, and third is 1, 7. Next I'll select second element of the first set and pair it with the first element, second element and third element of the second set. I mean 2 is paired with 5, 2 is paired with 6 and 2 is paired with 7. Next I'll select the third element and I'll pair it with the first element of second set, second element of the second set, and third element of the set, and I'll write it as 3 5, 3 6 and 3 7. We can see that here are total 9 ordered pairs which are the element of A cross B. So A cross B is not like a simple set, it is a set which contains its elements in the form of ordered pairs. We can tell easily what will be the number of elements in A cross B. We just need to multiply the number of elements in set A with that of the number of elements in set B. I mean that there are 3 elements in set A and also there are 3 elements in set B. We just multiply the number of elements in set A with that of the number of elements in set B, then we can tell directly that how many elements will be there in A cross B, and here this number is 9. Relations. For two sets A and B, all possible subsets of A cross B are called the relations from A to B. A relation is mathematically represented as R semicolon, first set A, an arrow and then B, and it is read as R is a relation from A to B. Let's take two sets A and B such that the element of A are 1 2 and that of the set B 5 6. If we multiply set A and set B, then we will get results like this: 1 5, 1 6, 2 5 and 2 6. The all possible subsets of A cross B will contain the elements in the form of ordered pairs. I know that empty set phi is the subset of each and every set, so phi is also a subset of A cross B. I am writing phi as a first subset of A cross B and it is as a first relation of A cross B. After that, I am going to write all the subset of A cross B which contain only one element in them as an ordered pair. And these subsets R2 means the relation number 2, first element of A cross B, 1 6, second element of A cross B, third element of A cross B, and 2 6, fourth element of A cross B. So all of these sets are making singleton set. After writing singleton sets as a subset of A cross B, I'm going to write the subsets of A cross B which contains 2 elements only. And I can generate these sets with the help of A cross B set. If I select the first element 1 5 and I make its grouping with the other elements, I can generate 3 possible subsets in this way: 1 5 with 1 6, 1 5 with 2 5, 1 5 with 2 6. Likewise, I can make another group of sets containing 2 elements with 1 6, 1 6 and 2 5, 1 6 and 2 6. I'm not writing here 1 6 and 1 5. The reason behind is that this set is equal to 1 5 and 1 6 set. So I don't want to repeat it. Repetition of sets is not allowed because I just want to get the unique sets. After this, I'll select those ordered pairs of A cross B which contains 3 elements. To generate this type of set, I'll make groups with 2 elements and relate it with the remaining elements one by one. Means I'm going to make group of 1 5 and 1 6. So I get R12 and R13. Next, I'll make the group of 1 5 and 2 5 and connect it with the next pair 2 6. Here is a mistake. I've written by mistaken 14 before and I'm changing into relation number 15. At the end, I'll make a group with 3 elements and relate it with the last element. And at the end, I'll join three elements in one group and relate it with the next element 2, 6. So I can generate a new relation in A cross B that contains all the elements of A cross B. We can write relation number 16 because we know that each and every set is subset of itself. So relation number 16 is proving that R16 is equal to itself and it is the subset of A cross B as well. I just want to share some extra information with you that we can write directly that how many relations we can make in A cross B. We have a formula 2 raised to the power n. By using this formula, we can easily tell that how many relations will be there in A cross B. N is equal to 4 here for this example. So if I put the value of n in 2 raised to the power n, I'll get 2 raised to the power 4, which is equal to 16. Domain of a relation. The set of all first elements of ordered pairs in a relation is called the domain of that relation. In the previous topic, we have found relations in A cross B, and one of those relations is relation number 13. And according to the definition of domain of a relation, it is the set having first elements of the ordered pairs of a relation. So the first element of the first pair is 1, first element of the second pair is 1, first element of the third pair is 2. If I want to write it in the set form, it is 1, 1 and 2. But according to the set theory, we can't repeat elements in a set. So repetition of 1 is not allowed. I can write it only in a single time. So the domain of R13 will be 1 and 2. Range of a relation. The set of all second elements of ordered pairs in a relation is called the range of that relation. For the previous example, I can find the range of the relation number 13, 5 and 6. I can see in relation number 13, second element in first pair is 5, in second pair is 6, and in third pair is 5 again. So the range of the relation number 13 will be 5 and 6. One element of this range is repeating itself, that is 5. But we can't write 5 two times because repetition of elements in a set is not allowed. So the range of relation number 13 will contain only two elements, 5 and 6. There is another method to write all possible relations in set A cross B, and that is called the methods of arrow diagram. In arrow diagram, we are writing one set in one shape and the second side, the second set in another shape. After that, we are writing the correspondence between the elements of set A and B. Suppose I am representing relation number 13 with the help of arrow diagram. One side I'll write the elements of set A and the other side I'll write the elements of set B. I'll make the correspondence between the elements of set A and set B and represent them with arrow. And I can easily get the domain and range set from this diagram. Functions. For two sets A and B, if R is a relation from A to B and it also satisfies the following two conditions. Number 1, the domain of the relation is equal to first set and there is no repetition in the elements of the domain of that relation. Then that relation will be considered as a function. In the previous topic of relation, we have solved an example in which we have found all possible relations A cross B, and let's now check how many of those relations are qualifying to be a function. If we are going to check for the relation number 1 R1, we can see that there is no element, so the domain of R1 is empty. Hence the first condition has failed, so R1 is not a function. Now for R2, we can see that it contains only one element, ordered pair 1, 5. And the domain of this relation R2 contains only one element. So the domain is not equal to set A. The first condition is failed for R2 and it is not a function. Likewise, domain of R3 contains only one element, domain of R4 also contains one element, and domain of R5 also contains one element. So all of these singleton sets are not qualifying to be a function. For relation number R6, we can see that the domain of R6 is equal to a set which contains only one element, which is not equal to set A. So it is disqualifying to be a function. In relation number 7, we can see that the domain of R7 is equal to 1, 2, which is equal to the first set A. So the first condition is satisfying. Now we will check the second condition. If first condition will satisfy, then we can go to the second condition. We can see that here is no repetition in the domain of set R7. So R7 is a function and we can write it R7 is a function from A to B. Next we are going to check for R8 is 1, 2, which is equal to set A. So first condition is also satisfied for R8 and second condition is also satisfying for R8 because here is no repetition in the first elements of the ordered pair of R8. Now let's check for R9. We can see that the domain of R9 is equal to set A and there is no repetition in the first element of the ordered pairs of R9. So R9 is also a function. Similarly, R10 is a function, R11 is a function, and R1 is not a function, R2 is not a function, R3, R4, R5, all are disqualifying to be a function up to 6. But R7, R8, R9, R10 and R11 are the functions. Next we are going to discuss the relations with 3 elements. We can see that the domain of R12 is equal to set A because one of the elements of R12 is going to repeat. So R12 is not fulfilling the condition number 2 and it is not a function. For R12 we can see that the domain of R12 is equal to set A. So first condition is satisfying, but we can see in the ordered pairs of R12 one element 1 is repeating. So R12 is not satisfying the second condition, which is important for a relation to be a function. So R12 is not a function. Likewise, R13 is not a function, R14 and R15 are also not satisfying both of the conditions to be a function. And these are not functions.